Okay, in this presentation we are going to look at linear combinations of random variables. In this particular case it's normal random variables, which is important. So let x1 be a normal random variable with mean 2 and variance 3, and let x2 be a normal random variable with mean 1 and variance 4. So what we're also to do is assume that x1 and x2 are independent. So what is the distribution of the linear combination of the random variable y, where y is 2x1 plus 3x2? And the second question is, what is the distribution of the linear combination w, which is x1 minus x2? Okay, so a couple of useful identities that will help us here. Now it's particularly the bottom few that we'll be using the most in this particular instance. And so here is one that we might be using, the expected value of ax plus bx, okay? And that is a times e of x, the expected value of the x variable, plus b times the expected value of y. Straightforward enough, just sort of separate it out like that. Now, the variances, so we have two here, the variance of ax plus by and the variance of ax minus by. They work out to be the same expression, a squared times the variance of x plus b squared times the variance of y, no matter if we're dealing with the difference or the sum of the two. So just to highlight that, plus, plus, minus over here, but still plus here, okay? So it doesn't really make any difference. Now really you can sort of rationalize that is that this is a coefficient is minus b, so when you square that it actually just turns into a positive number. B squared is positive, so that's why it would work out like that. Now, just an important thing actually, I sort of clarified that these were assumed to be independent, because if they were not, we would have variations of these formulas that would deal with that extra level of complexity where they are not assumed to be independent, okay? So these are when x1 and x2 are independent, or x and y as we are calling them in the identities here, okay? Now, the couple of other ones there as well, they're well worth looking at and well worth knowing about. But really, just for the sake of brevity, we'll just go with these ones here for the time being. But we will look at the other ones in other videos. Okay. So, what is the distribution of the linear combination y equals 2x1 plus 3x2? Okay. So, using the above identities, we can show that y is a normal random variable with mean 7 and variance 48. Okay, so the expected value of y is the expected value of 2x1 plus 3x2, which is 2 times the expected value of x1 plus 3 times the expected value of x2. Those expected values were 2 and 1 respectively, and we're just multiplying them by those constants there. So 2 by 2, where that was the expected value of 1 and x1, and then 3 by 1, which is the expected value of x2, which is 1 again. So 2 times 2 is 4, plus 3 times 1, that's 3. So 4 plus 3 is 7. Okay, now the variances. The variance of 2x1 plus 3x2. So here the coefficient is 2, and in this case the coefficient is 3. So we have 2 squared here and 3 squared there, okay, which turn into 4 and 9 respectively. Now, we're told that the variance of x1 is 3, okay, so we have 4 times 3, and we're told that the variance of x2 is 4, so we end up with 9 times 4. 4 times 3 plus 9 times 4 is 12, plus 36, and that is equal to 48. So, the y is a normal random variable with mean 7 and a variance of 48. Okay, so that's y there. Okay? Okay, I just paused it there to make a little correction. So this is part B. What is the distribution of the linear combination w, which is essentially x1 minus x2, the difference between x1 and x2. So w is a normally distributed random variable with mean 1 and variance 7, and that can be shown as follows. So the expected value of x1 minus x2 is simply the expected value of x1 minus x2, which is 2 minus 1, which is 1, okay? And the variance is of x1, that should be minus there, sorry, not plus, that should be minus x1 minus x2. That is equal to the variance of x1 plus the variance of x2. Okay, so that is a plus there. Okay, now a squared is 1. Okay, and minus b is also, when we turn that, is 1. Or so essentially minus 1 turns into when you square it is just 1. So that's how it ends up as plus anyway. So variance of x1 plus the variance of x2, 3 times 4, that is equal to 7. Okay, we'll leave it there.